Cluster member recovery. In this nugget, we're going to discuss what we need to do to recover one of our cluster members whenever a failure should happen, just throughout the day due to a power outage, a natural disaster, or even hardware failure for that matter. So the first thing we're going to look at are what are the steps to perform when an actual failure occurs. When you get the notification that something has broken in your cluster configuration, what should you do? And the next thing we're going to look at are the changes to the smart dashboard and the cluster config that we're going to make up and what we're going to change in order to recover from this failure. And then we're going to look at adding the firewall back into the cluster once we've made the changes and we re-imaged a box or replaced that particular node in order to get the cluster functioning as it normally would. We're going to add it back to our cluster. And this is going to be much like the cluster build process, but there are a few caveats that you'll see throughout this particular nugget. And then we will look at a discussion on the actual speed of recovery that a checkpoint cluster actually provides for you. Now, Checkpoint, as stated before, is going to be the global leader in network security products, and this is going to be one of the reasons why they are the global leader in network security. It's simply because the speed of recovery is going to be very beneficial for us, and we're going to review all the steps that it takes to recover our cluster members. So follow along, take some wonderful notes, and cluster member recovery is going to be a great tool in your tool bag. So let's discuss our cluster member recovery. Let's say, for example, one day you're sitting in a meeting when your cell phone starts to ring and buzz and make all kinds of noises with alerts from your network monitoring solution stating that the backup firewall in your checkpoint cluster is no longer accessible on the network. So you get out of your meeting and you run back to your desk and you pretty much figure out that the node is no longer accessible. You can't bring it up in Smart View Monitor, you can't ping the device, and your cluster has basically remained on the primary node. There was no situation that actually occurred that would cause a failover to actually happen, but it's not full on panic at this point, but it is something that you're going to need to address because you need to have some redundancy in your network, and that is why we build clusters in the first place. So in this nugget, we're going to discuss cluster member recovery, and we're going to look at exactly what we need to do to recover a gateway in our checkpoint clusters. So the first thing you're going to notice whenever you open up your checkpoint cluster here, and we see our nugget cluster as our actual object that we're going to use. If we open this up just in review, under cluster members we have nugget firewall 1A and nugget firewall 1B. And each one of these nodes make up the actual cluster that make up the nugget cluster. So if we go to the topology section and we click edit topology, what we notice is that pretty much just like during the build process for this cluster, we're going to see that there's a virtual IP of 10.20.1.1 and 172.20.20.2 that represent the VIPs or virtual IPs for each section of the cluster topology. Now we have those two, and we also have our sync interface that transfers our sync information between our two cluster nodes. Okay, so what we're going to see, and this is the main thing I want you to see, whenever you go to policy and you go to install. Now the default value you're going to see right here is install on each selected gateway independently. That is one option, but whenever you're working with clusters especially, you want to make sure this option right here is selected. And it's going to say for gateway cluster installs, you're basically going to install on all members. If it fails, do not install the policy at all. And the reason why we do this is because we don't ever want in the situation where we have a cluster for it to have two different policies. I've seen really bad things happen, and things will start getting really funny on the network, we should say, if we have different policies on each of one of our cluster nodes. We may have NATing problems or internet access problems or DMZ problems or all kinds of things that could occur should we get different policies loaded to different members in a cluster. So this is the one value to remember that we always want selected whenever we're pushing policy to a cluster. Now we may not have had that selected in earlier parts of this particular series, and that's okay for our lab environment here, but for a production environment, just remember that this little box right here needs to be selected, and whenever you're studying, you definitely need to be aware of this value and just make sure it's turned on. Alright, so we're going to hit OK, and as we stated, we're going to go ahead and actually install our policy to our nugget cluster. it's going to verify our policy as it normally would, and it's going to install our policy. Now, what we're going to see here is once we go to install our policy, we're going to get some kind of confirmation, as we normally would, that the policy was loaded successfully. So let's let this pop up here, and we're going to change some things up in the game here. Alright, so that looks successful at that point, right? So we're going to minimize this. We're going to go back to our desktop here. Let's open up our PuTTY session. And under our PuTTY session, let's connect over to our secondary firewall, which is our Nugget Firewall 1B, which is 1021.3. Let's go ahead and open that up, and we're going to log into it as under our admin account. Alright, so we're going to issue an IP space ADDR once we get into expert mode. And we're just going to use this to identify our particular interfaces that we're dealing with. So let's clean our slate and issue that command. And what we see here is our particular interface for the outside is ETH0. So let's say that's our outside interface. And our internal interface is our ETH2, which is the 10.20.1.3. So just to pose a particular failure in our network, we're going to do an IF down ETH2, okay? And that's for our secondary interface here for the inside of our particular nugget cluster for this particular node. So, and what we're going to do here is we're going to actually kill this particular interface. Of course, this is going to kill our SSH session, but what we're going to notice here is as we go into Window, and let's go into Smart View Monitor, we're going to pull this up, and we're going to notice on that particular node, the Nugget Firewall 1B, it's having a problem. It can't pull its status. It's in a waiting status right now. And basically, it's not going to be able to pull anything, and we're going to eventually get this, that the connection to that particular node has been lost. And this is typically what you will see whenever you have a cluster failure. You're going to get alerts if you have those type of alerting turned on with your network monitoring solution, or if you're sending alerts or thresholds or some type of email through your Smart View Monitor application here, you could do that as well occasionally. And where we're going to see these type of things at is under Tools. We have an option right here for alerts, where we can actually display a system or a system default beep or display alert window whenever something happens as a pop-up. But you can do those type of things. You can turn those on if you wish to do so. So anyone monitoring the actual checkpoint dashboards would see that information. But the point I want to make here is that we know that it's disconnected at this point. It's no longer accessible on the network. And whenever we do a policy install to our Nugget cluster, let's push this out, and this should fail for us. And this is what should happen in a normal process with your clusters whenever you have a failure. We should get this. We should get installation failed, and it's going to say that our reason that it failed was TCP connectivity over the 18191 port to this particular node. And basically, it's going to do a policy installation canceled for the remaining good node, the 1A. And that's typically what should happen. So how do you fix this immediately? So what is that first step that we need to take whenever we have a problem in our cluster configuration? Well, the first thing you're going to need to do is you need to restore connectivity, and you need to restore your ability to push policy to your cluster members just in case you have a change in the middle of the day. Now, running on one firewall for the 4 to 5 hours it takes to close out a business day isn't a bad thing, because in most situations, whenever you have a cluster that's built out correctly, the odds of you losing 2 pieces of hardware in one day are pretty slim. Unless there's obviously power or environmental issues or something to take into account. But what we're going to do here is we need to get ourselves the ability where we can get that policy out to the network. Maybe you get a call saying, hey, we need to create some new VPN accounts, or we need to push a new particular rule for a security or access or a NAT rule out to our organization so some of our business partners can get in or out. So what do we do to fix this problem? What we're going to do, and what I'm going to recommend that you do, is at this point you're going to do a file, database revision control, and I'm going to go ahead and say create a database revision control. And what we're going to do is just say cluster repair. Alright? Tell it to hit OK. Let it create that actual version for you. so you know exactly on what date you made your changes and you've repaired your cluster. So how do we fix this? We're going to actually go right here, and we're going to tell it to detach the Nugget Firewall 1B from our cluster. And what this is going to do is give us that one-legged cluster effect where we still have our virtual IPs in play, because all of our machines and all of our internal employees and everybody is going to use the virtual IP or the VIP address for internet routing and for DMZ routing or what have you. And it's okay that we can disconnect this one particular cluster member from the Nugget cluster in order to give us the ability to push policy again. So we're going to say yes to now, and it's going to say it's going to be defined as a VPN installed, and it's going to try to create an internal certificate for that particular node. So we'll click OK here. It says certificate operation was created, and it's going to ask us about some topology table and VPN link selection and all that good stuff. But for now, all we have to do is hit OK there for now. And this is due to the changes. Your link selection is no longer valid. Please select the link selection tab to configure it properly. So under VPN, we have link selection, and we can just tell it to use selected external IP for now. Alright, so that should take effect for us. Now, we can go ahead and save this policy, and once we save the policy, and we're going to have to go in, rebuild that particular cluster member, make any changes. Maybe we need to replace a server or some hardware or network interface card or what have you, whatever caused the actual problem. This will give you some breathing room to fix the problem. So now that we've taken care of that, we should be able to do a policy install and push our policy out to our Nugget cluster, which is going to install on this primary node in this cluster, which is our Nugget Firewall 1A. Now, something to keep in mind here, this type of scenario can work in either way. If you lose your primary member or your secondary member, you're going to be fine. As stated before, that is why we have a cluster. We build a cluster so we have that redundancy in the network, so when things do happen, we don't have a major outage for our company and for our employees. So at this point, we've installed our policy successfully. We can work on things throughout the day. We have that secondary cluster node, the Nugget Firewall 1B, out of the cluster, and we can work on it without it affecting the rest of the network. So what we're going to do at this point is go ahead and save our policy here, and then we're going to go into our Nugget Firewall 1B, make any repairs that we need to make, bring that interface back up. In our example, that was our way of demonstrating the failure, but we'll take care of that, get everything added back into our particular cluster, get our policy redeployed, and then we'll test out some actual failover scenarios, and we'll go through some common checklists that you want to do when anytime you're working with your cluster. Okay, so let's go ahead and take a look at our cluster config and get everything repaired. Now, we went ahead and rebuilt that particular cluster node. We brought the interfaces back up, and now we're going to look at re-adding that particular cluster member into our Nugget cluster. So what we're going to do is open up our Nugget cluster just like we did whenever we were building it. We're going to go to cluster members, and we're going to go to add. We're going to tell it to add gateway to cluster. So what we need to do is choose Nugget Firewall 1B. Hit OK here. It's going to give us a warning. It's basically going to say when Nugget Firewall 1B is added to the cluster, it will be converted to a cluster member and some of its data will be lost. But the following information will remain. It'll keep its SIC, it'll keep its topology, it'll keep its VPN, it'll keep its NAT information except for IP pools, and it asks us, are we sure we want to continue? So we'll say yes to this. And it'll create a certificate based on the cluster definition. And we have 1021.2 and 1021.3. Now the next thing you want to do whenever adding a cluster member back in is go to the actual topology menu, go into edit topology, and tell it to get the topology. You can get the actual all cluster members topology is what I'm looking for. We don't want to pull the topology for the cluster interfaces because that really hasn't changed. But we're going to go ahead and pull the actual cluster members topology and just make sure that everything lines up. Sometimes, and this is a point to remember, sometimes whenever you're re-imaging a secure platform machine or having to rebuild one from scratch, sometimes these interfaces could get moved around on you. Meaning, where we see ETH0 being tied to this particular interface in this particular IP scheme, we want to make sure that we have the same ETH number lined up with the topology after the rebuild. Now, I've seen in some situations where after you rebuild it via secure platform, and now and Checkpoint's gotten a lot better about fixing these types of problems during the later releases of Checkpoint R65 with some of the hot fixes that came behind it. But if, let's say for example, you need to replace a network interface card. Now the way that network interface card lines up in the actual netconf.c file or anything that is read off the rc.local or anything during the boot up process that makes up the network topology for this particular secure platform or Linux type box, it could move these interfaces around. So just one point to remember and one thing to check out is always go ahead and get all members topology and make sure whatever IP address you have tied to a particular interface, make sure that lines up on both of your cluster members. And you just want to make sure that everything is lined up correctly. That way your cluster is going to come up correctly and you don't have any problems. If you need to readjust some of your topology, that's okay. You can do that. There's no big deal. You just need to get everything lined up, readjust whatever you need to readjust on the topology information, and then get it all back into the actual cluster topology and you're going to be in good shape. So let's go ahead and hit OK here. Now we're going to hit OK here for now. Now the next thing that I like to do whenever I'm restoring an actual cluster member is I need to look at the actual SmartView monitor information, and I like to go ahead and just refresh it, make sure it looks okay, make sure it looks healthy and all that. Now one thing you're going to want to do is test the actual failover of your cluster. Now what I do recommend you doing, let's say for example, let's go ahead and start up an actual continuous ping out to the internet, for example. Okay, so we have this ping going. Now the thing we're going to want to do is go to our primary member, and you want to do this in a maintenance window if you can, after restoring a cluster member, because just in case things don't go well, you don't want to take the company completely down. So we're going to go ahead and stop the primary member at this point, which is this guy right here. Now looking at our actual ping times and our ping information, we didn't have any problems. Everything looks great. It's continuing to go out to our actual internet address of 4.2.2.2, so we know it's filling over correctly. It's natting like it should. And the next test that I like to do is just a simple trace route, and we'll run the -d command. That way it eliminates any DNS type lookups. So let's go ahead and run that, and we're going to see 10.20.1.3, which is the Nugget Firewall B, and we're tracing out to the network correctly. So that looks great. Let's go ahead and exit off of there, and we can go ahead and right click on here, go to cluster member. We can start this particular member, and this will just take a second for it to send the command over to the Nugget Firewall 1A, and we can refresh here, and it'll actually restore that particular member for us. But it's just going to take a second for that to happen, and once that happens, you'll be in good shape here. So that's actually, it's going to restore it. This is the primary member again. It is active. It's a high availability primary up. This is the Nugget Firewall 1B. I'm going to refresh that, and it should tell us that this is basically all the information that we want to know about this actual cluster topology information in just a second here. So what we're going to see is that our SmartView monitor hasn't caught up with the actual cluster topology information, and that's okay, because what it's showing is this is going to be our active member for the Cluster XL, and it's still not showing us anything about Cluster XL here. So let's go ahead and exit out of here, and that's a good point that I want to show you, is that whenever you restore your actual cluster member, it's a good idea to go in and verify all the cluster information after you have it back in the cluster and you have the actual policy redeployed. For example, you could that'll basically restart the Cluster XL process. But let's go ahead and open it up via the command line, and let's run through a few verification steps that I like to perform, and something you should know about as well. So let's give it a second here, and it should give us a password prompt, and then we'll log into this particular node. Alright, so let's go ahead and clear this after we get into expert mode, of course. And we'll clear off this particular node, and let's just issue a cpha prob stat command. Okay, so it's still showing active down. So what do we want to do here? Let's do an FW fetch from our particular Smart Center server, which is this. Now, we can fetch this information. Let's say, for example, you're out and about and you're restoring this at another location and you're not sure about your Smart Center server information. I want to show you how you can find that from an actual cluster member that is part of a cluster. So what we're going to do is we're going to do a change directory to $fwdir /conf, and we're going to do a more on the masters file. Okay, so on the masters file, you're going to see your nugget dash management. And if you have your DNS and different things set up, you'll be able to ping it by its host name. This will probably fail for us because we don't have a public or internal DNS set up. But that is basically where the actual cluster member and topology and all that type of stuff is kept for you, is in that masters file. So, like I said, that's going to fail because we don't have the DNS set up, but I want to just show you that information. But off that particular point for now, what I want to show you is after you get that cluster member in place, it's a good idea sometimes to go ahead and fetch your topology and your policy and your topology and all that good stuff from your management server. So we're going to fetch from 10.20.1.20. Okay. Says rejected fetch for this module. SIC name does not match to policy fetch failed. Okay, so that basically it's telling us that okay, you restored this particular cluster member, but that's fine and dandy, but the actual SIC information doesn't really jive with what I'm seeing in my particular management database, and it's a good idea that you probably want to go ahead and reset SIC whenever you're rebuilding a cluster member. And that's part of the steps whenever you have to reinstall the software or anything like that. Just like when you build a cluster member from the first time, you have to reset the SIC on that particular node. So what we're going to do is do a cpconfig. And after we get into this particular option, we're going to hit option number 5. And it's going to ask us, do we want to reinitialize our communication? We're going to say yes, and then we're going to put our SIC key in. Let's try it again. Alright, it likes us. So we're going to hit option number 10. And what we're going to see is it's basically going to go through and stop and start all of our checkpoint services on this particular cluster member. And this is going to run through the actual start of the processes. And then what we need to do is go ahead and open up this particular Nugget Firewall 1B, go to communication, do a reset, say yes to that, set OK. Go ahead and put our actual key in. And before you click that initialize, go ahead and make sure that the command line catches up with you first. So let's give it a second, let all the actual checkpoint daemons restart, let those get running, and let the FWD daemon and all that type of stuff come up properly, and it's going to basically be ready to go now. So everything's started, and it's telling us we have a SIC error right here, policy fetch failed, and that's okay because we know that. So we're going to initialize. Trust established. We're going to test our SIC status. It's communicating. We're in great shape now. Now, let's go back to the command line. We could do it via the dashboard, but let's try that fetch now. Well, see, it's still complaining about that particular SIC name, and that's okay. Let's go ahead and open up this particular member, do communication, test SIC status. It says it's communicating. Now, let's try our actual policy install. Push that out to the Nugget cluster and see what we get here whenever we check out our actual cluster topology information. We will run into that and we'll try our fetch again and just see what we get. And this should be successful after loading it from the dashboard because it's going to update all the files on that particular cluster node or that firewall saying, hey, you do have a good SIC name now. We just reset that with the management server. The management server's certificate database checks out and you're in good shape. So it says our installation completed successfully. Let's go ahead and close off of this. Go ahead and save our policy, and we'll give it a couple minutes. We're going to check out things via the command line. Okay, so let's check things out via the command line now. Let's try to actually issue our FW fetch to our management server. And Alright, we're in great shape. It's saying that our local policy is up to date. It's going to try to reinstall our local policy, and it's going to install the security policy standard on all.all.nugget firewall A2, or our secondary firewall. So what we have is we have restored our policy at that point. So let's go back and check things out via our actual SmartView Monitor application, and we should see some information about ClusterXL for this node. So we're going to go ahead and refresh this, and we see that the ClusterXL information is on this particular node again. It's the standby member in our cluster, as it should be, and this one is going to be our active member. So what we have done, we've actively detached it. We've actually restored our policy where we could get back into things. We rebuilt our cluster. We got it back in. We reset our SIC, which you always have to do. We actually pushed our policy out to get the ClusterXL, and the CPHA process is churning again. Now we just need to run through our basic cluster verification that we would normally use on our checkpoint clusters, which is CPHA prob. Let's do the stat first. Looks great. Clear that. Up arrow a couple times. -A space IF. Make sure all of our cluster interfaces are up. Everything's up. Looks great. Now we'll do our up arrow again, and we'll do a CPHA prob -I space list. Alright, so everything's up. It's in OK status. We're in good shape. Alright, so we can go ahead and get off the command line here. Log off of that, close out our actual SSH window, and we should be in great shape. So we can go ahead and exit out of our SmartView Monitor, and there we go. Let's go ahead and save this, and it's a good time to go ahead and build you another database revision control. And we can create this one. We can say that cluster restored. Alright, so we'll go ahead and hit OK here. Let it create our new database revision control. Alright, so this version was created successfully. We're in great shape. Let's go ahead and close off of that. Click Save here. And there we go. That pretty much makes up everything we need to know about our disaster recovery of our checkpoint clusters. In this nugget on cluster member recovery, we learned a ton of great information. The first thing we looked at were the first steps that we needed to perform whenever that actual failure occurs on our checkpoint cluster. What do we need to do in order to restore policy to our environment where we can push policy and get it out to our remaining good firewall, we should say, just in case we need to continue on with making changes for the business day, and to make sure that there are no outages or any slowdown in the business process just because we lost one of our cluster members. And then we moved on to an actual discussion about all the changes in the smart dashboard and some of the nice to have and things that we need to have set whenever we're pushing policy to a cluster in the first place. And then we detached it from the dashboard and made all of our changes and basically just rebuilt everything for this particular cluster node. And then we looked at adding the firewall back into the cluster, where we saw the changes that we need to be aware of whenever we're pulling our topology and resetting our SIC, which we have to do when rebuilding our cluster member. And that's basically brings us to that discussion where we were going to talk about everything that is the benefit of using a checkpoint cluster, and it's the speed of recovery. Now, a checkpoint cluster, as we can see, from the moment that we get notification of a failure, we can ultimately get policy running and get one of our remaining nodes as the primary member within seconds. We can detach the member, get the policy pushed out to the primary or secondary member in our cluster, and continue on with our day until we get time to repair our secondary cluster member like we did in this particular nugget. So, I hope this has been informative for you, and I'd like to thank you for viewing.